Hello everyone, welcome back to Spectrum Classes. This is our another video on the topic chromatography, and here in this video we are going to discuss paper chromatography and thin layer chromatography. In this video we are going to discuss the different type of paper chromatography and their basic principle, why it is called liquid chromatography, and partition is its basic principle, and thin layer chromatography is solid liquid type of chromatography and adsorption is its basic principle. So how it works, and the more important point which every student wants to know, how to decide the solvent system for chromatographic technique. So let's start with the video, and before going to discuss about the paper chromatography, let's have a look who have discovered this paper chromatography. So the credit goes to AJP Martin and his co-workers R. Constant, A. Jordan and R. Singer, who belongs to Cambridge School of Workers. So here in this paper chromatography, we are using cellulose filter paper, and this filter paper is covered with thin layer of water molecules due to its hydrophilic nature. Therefore, it is a normal phase liquid chromatography. So normal phase and liquid chromatography we are going to discuss here. So I'll just give you these pictures, and through these pictures I'm going to explain this in a better manner. So suppose this is our Whatman filter paper, and the composition of this Whatman filter paper is 9% alpha cellulose and rest are mineral contents, right? So this is our filter paper with this composition, and due to this its hydrophilic nature, it is the cellulose molecules which are present with this Whatman filter paper, they are attached to the water molecule in this manner. So here you can see, so if we are having this Whatman filter paper, so it is already having a layer of liquid, right? And solvent system is again we are using liquid, so it is a liquid type of chromatography. Now, since we are having liquid, so solute partitions itself between these two liquids. So the example of this partition is, you better understand, iodine in carbon tetrachloride and water. So here we have discussed this in our previous video also. So from here we get the partition coefficient, which is a constant. So in this manner, this Whatman filter paper or paper chromatography is a liquid type of chromatography, and partition is its basic principle. It's a series of equilibria of the solute between two layers of liquids. So this is our paper chromatography. So here I have mentioned what is called normal phase chromatography and what is called reverse phase chromatography. So I'll just give it with this picture. So if we are having polar molecules attached to the cellulose, in case of normal Whatman filter paper, water is the liquid layer which is attached to the cellulose molecule. So here stationary phase is more polar and mobile phase is less polar. Therefore, this type of chromatography is known as normal phase chromatography. Whereas if we are having same kind of picture here, and on this water or Whatman filter paper, if we coat another layer of wax or paraffin, so this brown color shows the paraffin film over this Whatman filter paper. So in that case, paraffin is less polar, and if we are using the mobile phase more polar, so here stationary phase is less polar and mobile phase is more polar, then this kind of paper chromatography is termed as reverse phase chromatography. Now coming to the ascending and descending paper chromatography. If suppose we are having this Whatman filter paper and this is the baseline, and at this baseline we are putting our solute, and this filter paper is now dipped in the liquid or mobile phase solvent system, right? Then the solvent is moving upward. Then this type of paper chromatography is known as ascending paper chromatography, which we generally use, right? If we fold it into two parts, this same filter paper, and we make this kind of arrangement, then suppose this is our solvent system here. At this end of this paper and we put our spots on top part of the back side here, and our solvent is moving upward, and on the backward side it is moving downward side. Here you can see in this manner, right? So this type of chromatography is mentioned as descending paper chromatography. Now coming to the solvent and solute system. So suppose this is our baseline and our solvent is below this baseline. On this baseline, we are putting our solute and it is moving along with the solvent. So solvent is moving upward and this solute is moving little lesser speed than our solvent. So why it is so? This is just because of the kinetic molecular motion of the solute, right? If this is polar, then it is wanted to be stuck on the polar molecules, which is the water system over stationary phase, and it is less likely to move with the solvent, right? So this is moving in this manner and it is leaving the, it is a mixture and it is having number of components, then it is leaving them either behind or they can move upward to this spot. Why these are having at different positions? So this is just because of this is more polar, this is less polar. If we compare more polar, why it is so? Because it is more likely to stay on the stationary phase rather moving with the mobile phase. So this is how one can understand. So this is less polar, this is more polar. Now coming to the measurement of their distance traveled by the solute and distance traveled by the solvent. So here this is known as ds, distance traveled by the solute, and this is distance traveled by the mobile phase or solvent phase, right? So at up to this center we are going to measure. Okay, so through this one can calculate the retention factor. So retention factor, how much time it is retained on the stationary. So distance moved by the solute from the origin line, distance moved by the solvent from the origin line. So here, just to have the separation for mixture of components, we should have retention factor between these two solutes at least 0.05 to 0.85. Otherwise, it is not possible to have the resolution here. So in this manner, this paper chromatography works. Now coming to the thin layer chromatography. So thin layer, first we are going to see who have discovered this thin layer chromatography. So TLC as a procedure for analytical adsorption chromatography was first introduced by Sehal in 1958, right? And in this type of chromatography, we are having a supports base, like here I am having glass plate, and in my previous video I have shown you the alumina plate also. So on this plate, we are making a thin layer of adsorbent. So what kind of adsorbents we are using? We are using silica gel, alumina, and some more adsorbents are also there. I have not summarized them here. So that is why this is called thin layer chromatography. So this thin layer of adsorbent is there on the support, either glass or metallic sheet, right? So here what we are using silica gel, which is acidic in nature, and the mechanism is adsorption, means the solute which we are putting or loading on this TLC plate, that is get adsorbed on this TLC plate, and that adsorbed solute will move upward side along with this solvent, right? So silica gel is acidic in nature and alumina G is basic in nature. So this silica gel is used for the acidic and neutral substance for separation, and alumina G is used for the separation of basic and neutral substances. Here, important point is that why this G is used in both silica and alumina. So here, the letter G indicates that the binder which is used here is gypsum, which is present in the adsorbent. And since we are using these adsorbents, so this adsorbent is solid, therefore we are using this solid liquid chromatography, and the solute is adsorbed on the adsorbent, right? So therefore solid liquid chromatography is our TLC and adsorption is the mechanism. Now coming to the selection of solvent system, which is very important. So here we are using Sahel's triangle for this. Here M is the mixture, and mixture, or we can say solute. First, we must know the nature of the mixture, whether it is hydrophilic or lipophilic. Hydrophilic means water soluble, or lipophilic means it is soluble in organics. Once we come to know the nature of the mixture, then we can decide the solvent system, which is also known as eluent. Right, so this solvent system can be decided by this triangle. Here E stands for eluent, M stands for solute or mixture, and S stands for stationary phase. So this is like this, and stationary phase we have already discussed. This is silica gel and alumina for acidic and basic component separation. So once we come to know our mixture, which is hydrophilic or lipophilic, then we move along with this triangle. So if it is hydrophilic in nature, then we will go for the polar solvents. If it is lipophilic in nature, then we should go for the non-polar solvent, right? And what about the stationary phase? Which kind of stationary phase we must choose? So we must choose, if it is hydrophilic in nature, then we use inactive adsorbents. And if it is lipophilic in nature, then we must choose active stationary phase. So here I have collected this information regarding the polarity of the solvent from the net. And here in this series, water is suggested as more polar and pentane is suggested as non-polar solvent, and rest of the solvents are arranged in their polarity order. So the combinations like 9 is to 1 and 9.5 is to 0.5, that has to be decided on their knowledge and according to the reference solvents reported in the literature. So in this manner, one can decide the polarity of the solvent which is used for separation in case of TLC or paper chromatography or in column chromatography. So this is how one can use this chromatographic technique, which is very simple and easy for separation point of view. So guys, the concept which I have discussed here, maybe you find it useful. So if you find it useful, give me a thumbs up and subscribe my channel. Thank you all. Thanks for watching.